Hi, and welcome back to the FE Exam Review Series, where we focus on problems built around core fundamentals that will help you pass your FE exam. Today's problem is based off of the mathematics subject, subsection B, multivariable calculus. I highly recommend you try the problem first before you watch this video solution, and you can do that using the first link in the description below. I highly recommend you try the problem first since that's the only way to really refresh the concept, and the FE exam is really all about practice. So every practice problem you do is getting you one step closer to passing the FE exam. I hope you tried the problem. Let's get into the solution. It says the three-dimensional vector field F is shown above. The curl of the vector field at any location is most nearly. Okay, so the first thing I like to do is kind of review what a vector field is. And if we draw a Cartesian plane here, every single position on this Cartesian plane will correspond to a certain vector. And you can get the magnitude and direction of that vector based off of plugging into the vector field here. Give me an x, y, z, and you can plug into the vector field and it'll give you a vector f. Now, where do we see vector fields? Vector fields can be used to communicate velocities in fluid flow, for instance. Every position inside of the fluid flow could have a distinct velocity. Its magnitude and direction could be differing, so that's one place that you might see a vector field. What about the curl of a vector field? The curl of a vector field, specifically, an example would be in fluid mechanics when we're trying to calculate something called the vorticity of a fluid flow, which is something related to how much swirl that vector field has. And the curl of a vector field is equal to what you get when you take the del operator and cross it with that vector field in particular. Now, the del operator is just the partial with respect to x in the I plus the partial with respect to y in the j plus the partial with respect to z in the k. So it's an operator of partial derivatives that point in the I, j, and k direction. When we cross it with the vector field f, we essentially have to perform some partial derivatives. The cross product is really contained in the determinant calculation. It's equal to what we get if we took the first row and made it the basis vectors I, j, and k. The second row is the del operator, which is the partial with respect to x in the I, the partial with respect to y in the j, and the partial with respect to z in the k. And then our vector field components. It's 3y in the I minus 2z, 2x in the j, and then z squared in the k. Now we went over expanding that determinant inside of a video that I previously did. So you can go ahead and check that out if you need a review of the determinant. Additionally, let's go ahead and check inside the manual, see where we could find a formula like this. On page 59 in the mathematics section, you can see that this is how we compute a cross product using the determinant up here. And additionally, you could see there's a section on the gradient, divergence, and curl, which are all kind of vector operations that represent different things physically, right? Today, we're going to be looking at the curl of a vector field, which is just the cross product between the del operator and the components of your vector field. Okay, so now we're going to go ahead and perform this calculation. Before we solve the rest of the problem, if you're enjoying this video and you're learning something, consider leaving a like and subscribing for more content like this. Additionally, if you're prepping for the FE Mechanical exam and looking for a resource that will help you pass, consider checking out my software, FE Interactive. It's the third link in the description below, and it'll give you access to multiple different sections, practice exams, review and improve sections, as well as a tips and tricks section, which helps you use your calculator better and save time on test day. An analytics page, which ties all of the different pages together. You get data for each of those pages where you can view, for instance, how you did on each exam, as well as a detailed solution manual for each exam so you know exactly where you're making the mistakes, what exactly is the misunderstanding coming from. And all of those are tied together with an overall data point. the overall data point can be reorganized in terms of performance so that you know what are my top three subjects, what are my bottom three subjects. Having this kind of data is super valuable since it helps you isolate your weaker points and fortify your strong ones. I'm confident that my software FE Interactive will help you pass the FE Mechanical exam. And again, you can check it out using the third link in the description below. You get 2 months of access for $29.99. Let's get back into the video. First thing we're going to do, we pretty much cover the first element. If we cover this I component, cover the row and column associated with it, what we see is that we get a smaller determinant, a smaller 2 by 2 determinant, which is the partial of z squared with respect to y minus the partial of negative 2x with respect to z. And this points in the I hat direction. Now that's how we expand the determinant for that first row, first column element. And first thing I'm seeing is that if you take a partial derivative with respect to a variable that's not contained in the function, like you can see this is a function of z, and we're taking a partial with respect to y, we're going to get a 0 value there. That's essentially like having z squared y to the 0, right? Y to the 0 is 1, and 1 times anything is itself. So this is equivalent to just z squared. If you kind of use the power rule here and drop down that 0, when you're taking the partial derivative, then you're going to get a 0 value for this function, and the z squared is considered a constant when you're taking a partial derivative. Okay, so the first thing I know is that for sure the first component is 0 in the I after we compute it. What about the second component? Now the second component, we do the same thing. We do the j component. We'll cover the associated row and column and expose the smaller 2 by 2 determinant. Now, remember that there are signs associated with the determinants, and there's this kind of checkerboard pattern of pluses, minuses, and pluses that kind of trickles down throughout the determinant. And these are the signs that you have to apply. That j component will have a negative sign because it is the second row, it is the first row, second column element, so it has a negative sign. And we have a smaller determinant to compute. This one is the partial with respect to z squared, partial with respect to x of the function z squared minus the partial with respect to z of the function 3y. And this entire thing points in the j. Again, the same argument. You can see that this function z squared doesn't have x's. This is going to be 0. The function 3y doesn't have z's. This is also going to be 0. So we have plus 0j. And what about the last component here? The last component is that k hat component. The last component is that k hat component. It has a positive sign. So we're going to put a plus here, and we're going to compute our last set of partial derivatives. We have the partial of negative 2x with respect to x minus the partial of 3y with respect to y. And that points in the k direction. If we go ahead and compute what this is, the partial derivative of negative 2x with respect to x using the power rule, what we get is negative 2 for that one. And then we have minus the partial with respect to 3y. Partial with respect to y of the function 3y is going to be 3. So we have negative 2 minus 3. That's going to give us negative 5. And that's pointing in the k hat direction. So this should be our answer to what the curl of that vector field is. And one thing that you can note is that the curl is a constant value for this function, and it could be a function of position as well. The curl could change at different positions inside of the vector field. This one is just a constant upward, constant vector kind of into the page. Its magnitude is negative 5. Okay, let's go ahead and input the answer here. Negative 5 in the k, we can check it, and we can see a written solution here that kind of has that reference. page 59, and all we did was we essentially performed the cross product of del and f. We reviewed the idea of a vector field, and after performing that cross product, where we used the del operator as the second row and the vector field f, the components of that vector field, as the third row, we're able to compute the partial derivatives, and we saw that the first two components were essentially zero, and the last component computed to a -5 value. The final answer was choice C. If you enjoyed this video, consider leaving a like and subscribing. Thanks for watching. I'll see you in the next video. Goodbye.